Okay, so this video is about energy and power and electricity. So energy is the capacity to do work. So you need energy to do work. And power is the rate of energy transfer, or the rate at which energy is used. Our unit for energy, our main unit, is joules, J. And the unit of power is about the rate of energy. So it's about energy per time. So power equals energy per time. So it's going to be joules per second. Now, instead of just saying joules per second, physicists came up with a different unit, which they call the watt, symbol W. So if you have power of 1 watt, that means 1 joule is being transferred every second. If you have 2 watts, that means 2 joules is being transferred every second. And if you have 1,000 watts, then they call that 1 kilowatt. And that would mean 1,000 joules are being transferred every second, or 1 kilojoule is being transferred every 1 second. So watt tells you about the rate at which energy is being transferred. In electricity, it's actually fairly easy to calculate power and to calculate energy. When we calculate power in electricity, it's actually the current times the voltage. Current times voltage. Remember that current is in amps and volts is in volts. And that doesn't really help us much, but if we break down what they are, an amp is a coulomb. I can do it. Coulomb per second. So it tells us about how many coulombs of electrons are transferring every second, whereas voltage tells us about the joules of energy that's on each coulomb. And if we multiply those two things together, we'll see that the coulomb part cancels out, and I'm left with the joules per second, which is exactly what I had up here, the joules per second. So when you multiply current and voltage together, you end up with power. So you end up with watts. So if you take 1 amp of current and you have a 2-volt battery, then you'll end up getting 2 watts of power. So the power of that device, how quickly is it using electrical energy, is 2 watts. So you just multiply the current and the voltage together. If you want to get to energy, so that power is how quickly you're using the energy, to get an energy value, you need to also know how long you were doing that for. So energy is power times time, which in electricity terms is current times voltage times time. So if we take that same example, if I use a 1 amp of current and I've got a 2-volt power supply, and let's say I do that for 1 second, then 1 times 2 times 1 equals 1. And that would mean that I had actually transferred 1 joule of energy, or I had used 1 joule of energy. So the amp times the volt gives me a watt, and a watt times a second is a joule. I know that these units get very, very confusing. There's a lot of different letters. I appreciate that. We'll keep them on the wall and we'll keep practicing. Let's do slightly different numbers. So energy, if you've got 5 amps and you've got a 10-volt source and you do that for a minute, so you do that for 60 seconds. So 5 times 10, that means the power is 50 watts. And then when you do 50 watts times 60 seconds, then you should get 3,000. That means you would have used 3,000 joules. So 50 watts this is the rate at which you're using energy or transferring energy. 50 joules a second. And then since you do it for 60 seconds, this is the total energy used in that 60 seconds. So you used 3,000 joules or 3 kilojoules, and you were using them at a power of 50 watts or 50 joules per second. So that's really all there is to power and energy calculations: current times voltage for power, current times voltage times time for energy.